Now that we know what factors are, let's discuss how to find the factors of a number and what they tell us about the number. So how do we factorize a number? Say I have a number 72. I know this is 8 into 9. I break it down into simpler components, but I have to bring it down to its prime factors. When we say factorization, what we imply is prime factorization. What that means is that we need to find the prime factors of 72 and also how many of those prime factors are there. That is the exponent of each prime. So when I say 72 is 8 into 9, this is essentially 2 cube into 3 square. That means that I have 3 2's and I have 2 3's, and all these factors together, they multiply to give me 72. So this is the prime factorization of 72. Now, if I were to find how many total distinct factors does 72 have, how will I do that? Of course, realize that 72 has a lot of factors. We find that it has two factors, two prime factors, 2 and 3, but it has a lot of other composite factors as well. And it has 1 as a factor as well. Of course, every number has 1 as a factor. 2, 3, 4, 6, 9, then 12, then we have 24, we have 36, we have 72. Did we leave anything? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 into 3, 12. Yes, we've left a couple of factors as of now. So 8, of course. 8 will be there. And 9 is there. 12 and 6 is fine. Then 4 and 18 will be there. Okay, so overall, we have 12 factors. Now, did you see that it was really hard to get all 12 of the factors, right? Now, what if there is a bigger number with more prime factors, with lots of different exponents? It will be very hard to get all the factors, isn't it? Of course, so then there has to be a proper method to this madness. So then what is that method? Let's say if I want to find all the factors of 72, I'll say that there are 4 ways in which I can pick a 2, and there are 3 ways in which I can pick a 3. Of course, we have only 3 2's and only 2 3's. So then you might ask me that, what are you talking about? Now, this is what I'm talking about. I say a factor. There are 4 different ways in which I can pick a 2. I say I do not pick a 2 at all, or I pick a 2. Or I pick 2 2's, or I pick 3 2's to make a factor. Then in this case, now I have 3 choices to pick a 3. I say either I pick no 3 at all, or I pick 1 3, or I pick 2 3's. And the same will be repeated for each one of these. So then in how many different total ways can we make a factor? In 4 into 3 ways. 4 are the ways in which we can pick up the number of 2's, because we can pick up 0 2's, we can pick up 1 2, we can pick up 2 2's, or we can pick up 3 2's. And 3, there are 3 ways in which we can pick up a 3. So 3 0, or 3 1, or 3 2. So that is why overall we have 12 different ways of making a factor. Look, this is no different from what we discussed in combinatorics as well. If one thing can be done in 4 ways and another thing can be done in 3 ways, then the 2 things together can be done in 12 ways. So this is exactly what we are doing over here as well. So then notice that when we have a number n equal to x to the power p into y to the power q into z to the power r, then the total number of factors are given by p plus 1 into q plus 1 into r plus 1. That is, whatever are the exponents, then plus 1, and then all are multiplied together. So then if I were to just take any random number, let's say 2 3 into 3 square into 5 into 7 cube, what will be the total number of factors over here? It will be 3 plus 1 into 2 plus 1 into 1 plus 1, because 5 is to the power 1, into 3 plus 1. So the exponents of each of the prime number, they'll be increased by 1, and then all of these will be multiplied. That will give me the total number of factors. Y plus 1, again, let me tell you why plus 1, because we'll still get a factor if we don't pick up this particular exponent, right? For example, when we have 9, let's say if 9 is a factor of 72, it doesn't have a 2, right? But it has a 9. So we still get a factor of 72. Now, when we don't pick up a 2 and we don't pick up a 3 as well, then which factor do we get? 1. And this is always one of the factors of any number, right? So when we don't pick up any prime factor, then we get 1 as the factor. So let's take a look at an example now. How many total factors does 360 have? Now, first of all, we'll need to prime factorize 360. Now, the easiest way, especially if it ends with a 0, is, let's say I'll break it down into 36 into 10. 10 I know is 2 into 5. 36 I know is 6 square. 6 square means that it is 2 square into 3 square, and 10 is 2 into 5. So then what is the prime factorization of 360? It is 2 cube into 3 square into 5. So then how many total factors will 360 have? It will have 3 plus 1 into 2 plus 1 into 1 plus 1, because 5 is to the power 1. That is 4 into 3 into 2. 24 factors. All right. Now, which are going to be these 24 factors? Of course, that is going to take some effort for us to write down. So right now, we'll not worry about it, but we'll see exactly how they are all related. All right. So let's write down all the factors of 72 that we came up with. Say 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Now notice that when I multiply the smallest factor, which is 1, with 72, which is the greatest factor, I get a product of 72. When I multiply 2 with 36, I again get a product of 72. Now, obviously, does it make sense that the factors appear in pairs? It certainly does. Why? Because which number is called a factor of a number, say 72? When will I say that A is a factor of 72? When there is another integer that exists, which when multiplied with this number will give me 72, right? If there is a number B, which when multiplied by A gives me 72, then I'll say that A is a factor of 72. So whenever I have a factor of 72, I have to have a corresponding B to it, right? If I say that this is A, which is a factor of 72, I must have a corresponding factor B, which I get when I multiply this A with this B, right? I get 72 by multiplying this A with this B. All right. So then when I have 2 as a factor of 72, then the corresponding factor would be 36, such that 2 into 36 will give me 72. When I have 3 as a factor, then 3 into 24 will give me 72. 4 into 18 will give me 72, 6 into 12, and 8 into 9. So basically, the factors all appear in pairs and they multiply to give us 72. That definitely makes sense, right? Okay, great.